Okay, good evening, everybody, once again, and welcome to this evening session, the Monday evening session, live session where we go deeper into the concepts. We learn few important concepts, practice with Minitab, clarify our doubts. Okay, go deeper and become more and more confident about the subject. Okay, so before that, let's complete our ritual. Who are the new people in the room? Just type me in the chat box and let's welcome them wholeheartedly. Who are the new people? Just type me in the chat box. The first timers, the people who are attending the session very first time. Okay, Mr. Atul, Umesh, Salam Deepak Singh. Okay, who else? Who else? Type in the chat box. I think a lot of people are yet to join in. Super. So everybody, please type welcome new members in the family. Give them the warm welcome. Let them feel like home. Welcome, welcome, welcome. Amazing. Everybody, just welcome them wholeheartedly, and let's join, grow together as a family, as a unit. All right. Amazing, amazing, super. Chalo, everybody, let's. So, what's the topic we are going to discuss? We are going to discuss what is the topic today. Very interesting topic. I've actually we are going to go today deeper into. Yes, super, super, guys. So, discrete control charts. Very nice. So, today, see, on Saturday, we had taken continuous control chart, if you remember, right? On Saturday, we had continuous control chart. Now, the people who have just joining, you must be having your login ID password, right? Just type yes in the chat box. Hope you have got login ID and password. Everybody. Super. Now for them, there is a folder called Masterclass Archive, Lean Six Sigma Live Masterclass Archive, where all the live session recordings are basically placed. All right. Now, over there, for the new members, just go through the session which was conducted. So just scroll it down at the bottom of it. Okay. You will find a session with the date 7/12/24, which was exactly on Saturday. So whenever time permits, just go through this session. Okay. The people who were there already, they have attended this. But for the people, especially the new people, just go through this decoding control chart session, which we have taken one day before. Okay. That will, so today's session and this session, you will get a complete picture of the control chart. Are you clear, everybody? The new members, are you clear? And whenever you are not able to attend the live session, you will get the recording in the masterclass archive, the same file, the same folder. Clear? Just give me yes in the chat box, everybody. Okay. Now let me, yeah, you can just give me the confirmation so that, yeah, especially the new people. The seniors already know this, but the especially new people. Okay, now there are two types of data. Whenever we collect the data, there are two types of data generally find. So whenever we collect the data, there are two types of data we will find. Okay, one is called continuous data. Write this down. One is called continuous data. The other one is called discrete data. So the today's topic, we are going to touch upon this. On Saturday's topic, we covered this part of it. Okay, so if you see the recording of that, you will get a holistic picture. But what is continuous and what is discrete? Continuous is the data which can be measured on continuous scale. The data which can be measured on continuous scale. So that's why it's called continuous data. What is continuous scale? For example, let's say if I'm measuring the length. Okay, So let's say I'm measuring the length in the centimeter. So 1 centimeter, 1.1, 1.2, 1.3, 1.8, 1.9, 2 centimeter, 2.1, 2.2, 2.3. So on a continuous scale, I can measure the length of any article, any, anything, right? It's called continuous data. So example is length, width, height, temperature, pressure, all these things are basically continuous data which can be measured on a continuous scale. On the other side, discrete data is the data which cannot be measured, but it's counted. Okay. Now, by the way, continuous data can be expressed in decimals. It is expressed in decimals. So I can express 1.2 centimeter in decimals as well. Okay. So it is measured. It is counted. Discrete is counted. Okay. Sorry, this is continuous scale. Instead of data, you just write continuous scale. Okay. So this is not continuous. This is a discrete scale. What is discrete scale? 1, 2, 3. It is there. There is no nothing between. For example, if I want to count the number of people right now in the room, let's say there are 40 people in the room. Okay, so we are counting the number of people. We are not measuring the number of people. Understand this? And there is nothing in between 1 and 2 and 3. That nothing like 1.1 people and 1.2 people. Are you understanding? It is called discrete. Okay. So, for example, male, female, pass, fail, go, no go. All these are discrete data and generally can't be expressed in decimals. Are you clear the basic fundamental difference between continuous and discrete? I just type yes in the chat box. Are you clear with this? Just type yes. Very good. Super. Anybody has any doubt, especially new people, you can ask me 100 times. I will explain. Okay. Very nice. Chalo. Now, whenever we are learning the concept, try to connect the concept with your own example. Okay. Can we just do this right now? In your process, give me one example of continuous data. Give me one example of discrete data. Can you just do it right now? Think about your process and type in the chat box one example in your own process, okay? Whichever industry you're from, just type C for continuous and D for discrete. Okay, just type in the chat box and let me read out quickly so that other people also will read out. D is number of team members, fantastic. Profit and loss, fantastic. C, just type C or D in the chat box. C for continuous, D for discrete. Diameter of the shaft is continuous data, fantastic. What is that? Metric ton, yes. Metric ton is continuous data, very nice. Amount. Average handling time, it's a continuous data. Yeah, so 1 is discrete, 2 is discrete, 1.12 is continuous, fantastic. Discrete is pass and fail. Number of child is a discrete data, fantastic. So let's say somebody has 2 children. So 2 is discrete data because you are counting the number of people. Clear everybody? Funda clear hai? Whenever you are learning the concept, try to connect with your own process. Then it will make more sense. Your understanding will become deeper. Okay. So now understand this. So when we collect the data, whether the data is following a stable path or not. Okay. Whether the data is following a stable path over the period of time or not, that it's called stability check. Okay. Have you noted down? Shall I wipe it off? Just give me a yes, or you can take a screenshot of this. You can take the screenshot or you can just take the notes along with me. As I'm writing, you can also write along with me so that, you know, yeah, you can just take the screenshot because it will be wiped off because then I'll have to write something else as well. एक बार screenshot ले लीजिए ना, ठीक है? Done? Super. Chalo. So now let's understand there is something called stability. Now, stability is something which is a very important behavior of the process. Stability meaning, on Saturday also I gave this example, okay? Let's say a disciplined child, the same example I'm continuing so that it's very simple and easy to understand. There is one disciplined child and there is one undisciplined child. A disciplined child gets up at 6 o'clock, becomes ready for the school at 7 o'clock, goes to school exactly at 7:30, comes back at 1 o'clock, studies till 3 o'clock, maybe take rest for 1 hour, then, goes for his physical exercises. It's very stable pattern. Stable meaning predictable. Now, at any given point in time, if you ask at 1 p.m., what would be the stable child doing, disciplined child doing, so you can easily predict. And the same goes with the process. Same goes with the process. The father of statistical process control, SPC. How many of you are aware of SPC? SPC किसको मालूम है? How many of you are aware? How many of you have heard about SPC? Yeah, a lot of you. Yeah, some of you are not aware of it. No issues. So, SPC is statistical process control. Statistical process control. Okay, yes, exactly. So stability, process capability, all are the part of SPC, statistical process control. And father of SPC is Walter Shewhart. Walter Shewhart, okay? Just. So he is the one who basically started SPC. So almost 100 years ago, he started this fundamental that if any process within +3 and -3 standard deviation, if this is a process, okay? So within +3 and -3 standard deviation, if this process is flowing, this process is, this is the X bar, this center line is X bar, the average. This process is said to be a stable process. Okay? Clear here? So according to Walter Shewhart, when he invented this, when he started this, any process which flows between +3 and -3 standard deviations band, that process is stable and predictable. That's why and this is called control chart. Whatever I have plotted, it's called control chart. And that is our topic today. Discrete control charts. Okay. So there are various types of control charts, out of which we are going to learn about discrete control charts. Okay. Which basically checks the stability of the process, the predictability of the process, whether it is really stable and predictable or not. Okay. So what are the general types of what you can say control charts? Let me show you a table which is also available in your green belt curriculum. Okay. First, let me just quickly explain you this. All right, look at this. So this is the table which is for, now do you have to remember this? I'll just simplify this. So the first first decision. So whenever you come across this kind of a diamond like this one, okay, this is a decision box. from the decision box, there will be two outputs which will be coming out. Okay, one on this side, one on this side. Okay, so right now the decision box says, is the data continuous or discrete? If it is continuous data, then you have to follow this path. If it is discrete data, you have to follow this path. Okay, so on Saturday, we have covered I chart, X bar R chart, and X bar S chart. So that recording which I showed you in the masterclass archive, you can find this entire portion over here. ये वाला left side का जो portion है, that portion you can find in the Saturday's live session. Now today we are covering discrete data. Okay. Now in the discrete data, the next question, now let's say continuous and discrete. So we are going for discrete. Okay. So in the discrete data, do you have defect data or defective data? Now this is very, very important. So is it defective or defect? Let's say defective or defect. Now this is, let me explain you this concept. Okay. Same example I will carry forward. Let's say I'm the shirt manufacturing company. I'm making shirts. Okay. Now, as a quality person, my role is to check the product and check the quality of the product. Is there any defect in the product? If I found any defect, I will reject the product. That is called defective. If that entire shirt gets rejected, that is called a defective product. If I'm collecting the data of how many products are defective in my process, that is called defective data. Now there is another data called defect. What is defect data? Now in one shirt, in one unit, okay, in one product, there could be multiple defects. For example, there could be stain on the shirt, there could be button missing, okay, or there could be some stitching defect. So there could be multiple defects in one product. Are you understanding? So if I am collecting the data of defects, then that will be called as defect. If I'm collecting the data of how many shirts are defective, that will be called as defective. Are you clear with this? Just type yes in the chat box. Are you clear with this? Super clear? Just give me yes in the chat box. Sorry. Initially, we used to actually collect the data of defective only. Understand this? Huh? And now this is very, very interesting thing. Now, which one is more important? Let's understand. Now, let's say, imagine I am the quality checking person. I'm checking the product. The moment I find one defect, I will reject the entire product. Yes or no? And that I will declare as defective. Now we have counted, there could be three defects, three potential defects like stain, button missing, and stitching defect. Okay. There are three potential defects. Now, the moment I find one defect, let's say a button missing, I will reject. So I will never go ahead and investigate the other defects. Understand this? So I will be actually losing a lot of information on the other defects. How many of you got this? Just type yes in the chat box. So I'm just comparing between defective versus defect. Which one is better? So the moment I find one defect in the product, I will reject that product. I will mark that product as defective. Okay. But on the other side, I will lose on the information on the other defects because I'm not counting them. Now, instead of this, if I start counting defects rather than defective, I will get more information. How many of you got this? Just type yes in the chat box. So earlier, people used to find out defective, the rejection, the ppm, parts per million, meaning how many parts per million are rejected. Now we are going for defects, DPMO. That's a change. with the help of Six Sigma. That's an improvement we have done. Okay, so defects always gives us more information. Clear hai? Are you clear? Now, when, so defect or defective. Now, here, if there is a defect, we will follow this path. If there is a defect data we are having, we will follow this path. If we have defective, we will follow this path. Okay. So in defect, let's say there is another what you can say decision. Is the sample size constant? Okay, this is the same question asked in both direction. What is sample size? Let's say in let's say one shift we are taking 50 shirts. Second shift we are taking 70 shirts for quality checking. I'm talking about that is called sample size. Now I have explained about variable constants, variable sample size. If we are taking all the shift, we are taking 50, 50, 50, 50, 50 samples for checking. That is called constant sample size. If that is the case, and we are having a defect data, then we'll follow this path and we will check the C chart. Okay. And if the sample size is not constant, then we'll go for U chart. Okay. On the other side, if you have defective data and the sample size is constant, we will go for NP chart. If the sample size is not constant, we will go for P chart. Now, do you have to remember this? There are only 4 control charts: C chart, U chart, NP chart, and P chart. There are only 4 control charts you have to use. Okay. So there is nothing to remember much. Only 4 control charts we have to remember. Okay. I will make a table for you as well. Just take a screenshot of this. I will just make a simple table as well. Just take a screenshot of this. I will share this document as well. I will share this document below the recording. You can just download this document. You can. And this table is, this tree diagram is already available in your green belt curriculum. Okay, so it is already available, given. Done, everybody? Just give me yes in the chat box. I will make a simple table to remember this. Done, done, done. Very good, very good. Chalo. So let me just make this simple table. Then we will do some Minitab exercises around it. Okay. Minitab exercise से आपको पता चल जाएगा कि कैसे करना है इसको. ठीक है. So draw this table. Constant sample size, variable sample size. All right. Then you have here, you have defects and you have defective. Okay. So just make a table like this. Everybody just make a simple table like this so that you can easily remember this. Okay. Okay. So the same tree diagram I've just condensed. This is only for the discrete data, by the way. Only 4 charts you need to, 4 control charts you need to remember. If you have defect data with constant sample size, go for C chart. If you have defect data with variable sample size, go for U chart. If you have defective data, constant sample size, go for NP chart, and defective variable sample size, go for P chart. That's it. Okay. Just take a screenshot or just make a note of this. And let's Let's go one by one. We will just first we will do a C chart. Can you just download this file of Minitab? I've just given the chat. Now, if you have, for the new people, guys, understand this. If you have laptop or the desktop with Minitab installed into that, okay, then only you can just you can download this file. Otherwise, today is the first live session. Just observe what we are doing. Okay. If you have downloaded Minitab with you on your laptop or desktop, then only you can correct. You can just download this. Okay. The rest of the people having Minitab software. So anyway, whenever we are having the live session, no, come with and if possible, if you are not traveling, etc. Okay, then you can use this. Okay, yeah, just click on that. Click on any of this. This is the same file, C chart. Okay, the name of the file is C chart. Yeah, once you have done, just type open with the chat box. Open होने के बाद just मुझे बताइए open कर लिया है कर. Super. Done. Just give me done in the chat box. Chat में I have already given you a file called C chart. Just give me yes in the chat box if you have downloaded that. I'm waiting for everybody. Sure. So let's look at it. So when do we use C chart? When do we use C chart? When we have defect data and constant sample size. Just try to understand this. Defect data and constant sample size. Now, there is a teacher who is checking the question paper of the students. Okay. So now here is for every question paper, obviously the number of questions are going to be same. Yes, everybody. So this is called constant sample size. Right? Let's say there are 50 questions, or let's say there are 20 questions. So the sample size will be same, right? The question number of samples will be same. Out of which, how many errors, how many wrong answers they are giving, they are considered them as errors or defects, right? So this is paper number 1. The student has made 4 defects. Paper number 2, students have made 2 defects. Paper number 3, students have made 1 defect. Okay. So this is the data. Are you clear with the data? Just type yes in the chat box. So constant sample size, because constant questions are there. Questions are common and constant across all the question papers, right? Now, out of which, how many wrong answers they have basically given. That is what the data is. That is the defect data, correct? So we'll go for the C chart. So go to stat. How do we actually make C chart? Go to stat, control chart, attribute chart. Now attribute meaning discrete only. Okay, attribute is equal to discrete. Okay, so attribute chart, and you will find C chart. You can see the last. I'll just follow this path. In the menu bar on the top of it, there is a stat option. Stat, go to in the stat, the 5th option is control charts. And don't worry about how do we remember the sequence, right? It's all about the practice. Okay. Control chart, go to attribute chart and the C chart. Everybody following me? Just type yes in the chat box. So here this window will appear. In the variable column, you just have to select errors. That's it. Don't do anything else. Yeah. Just select error column, double click on error column. Okay, if this is like this, just click in this column and then double click on error. It will get selected and say, okay. Look at this. So this is the chart. Now, any data which is going beyond control limit. Now, there are 3 data points. You can see in red. They are called special cause of variation. Write this down. And the data point between these 2 lines, between the control limits, upper and lower control limits, this is called common cause variation. Special cause variation and common cause variation. Whenever there is a special cause variation present, the process is not stable. Here you can see special cause. There are red dots can be seen on the chart. That means the process is not stable. In this case, you need to investigate what has happened, why more number of defects are created. All right. And this is where we need to investigate this. What about the LCL touching points? Now, LCL touching points. Now, LCL, if you observe, it's stopping at 0 because we cannot make minus negative errors. Are you understanding? So the lowest error we can make are 0. Are you understanding? So in these numbers, for example, student number, let's say this is 15. Example, I'm giving you example. Student number 15 has scored 0 error. Student number 19 has scored 0 error. Student number 25 has scored 0 error. 0 error, meaning out of marks he has scored. Again, student number 64 has scored 0. 0 error, meaning no errors. All the questions are right. All answers are right. Okay. So this is why the lower control limit is stopping at 0, because we will never have negative error. We cannot make negative error, right? Until there are negative marks, etc. Okay. So there are no negative errors here. That's why the lower control limit is at 0. Okay. So this process is not stable process. We need to investigate over here. Okay. Now we need not to investigate the lower control limit because it is good, no? If the errors are becoming 0, it is good for us. Yes or no? Are you understanding this? Just like yes in the chat box. So if the errors are becoming 0, okay, that is absolutely what you can say acceptable and expected situation. But if it is going beyond 10, etc., that is where we need to investigate. So these 3 students need some investigation and the process is not stable. So any data point goes above control limit, it's called unstable process. It's called special cause variation. And this entire process needs to be investigated, especially those three data points. Okay. Yeah, for centerless grinding, how to take 100 samples for SPC if dress frequency is 30 numbers only. So you can take 30. No, it's not necessary to take 100 data points. You can take lesser data points as well. But at least 30 and above. At least take 30 and above. Okay. Yeah, you can take that. Agar 100 possible है, you can take lower. But 30 से नीचे मत जाइए. Are you clear with the C chart? Just like yes in the chat box. This is called a stability diagram or a control chart. Clear है यहाँ तक? Just type yes in the chat box. Everybody got this diagram? Super, super. Amazing. Now let me share with you another graph. Whenever you have defective data. Now this is a defect data. If you have defective data, then you go for NP chart. Okay, go for NP chart. So I'm just sharing the NP chart file. You can just download the file and open that file. We will do the NP chart now. All the 4 charts we will do. and then we will discuss. Once you have done it, let me know in the chat box. Yeah, done. Open. Have you opened NP chart? Just give me a yes in the chat box. It's a mean. It's a mean of the data set. It's the average score of the data set. Yes. Done. Opened, everybody? Super. Now let's understand this. Now these are the defective data. Let's say there are 50 samples each. It's a constant sample. And these are defective. Out of 50, on the first case, one rejected. Out of 50, one rejected. Out of 52, rejected. Out of 52, rejected. So this is the data we have. Now let's go for NP chart. The same process we need to follow. Attribute chart, and you will find NP chart over there. Just follow this process. Go to stat, control chart, attribute chart, NP chart. Stat, control chart, attribute chart, NP chart. Okay. Just click on NP chart. Now here we need to, in the variable section, we need to check the count data. Double click on count data. And in the subgroup size, either you can type 50 or you can double click on sample data. Both are okay. Either you can type 50, 50, or you can just double click on sampled column. Both are same. Okay. And just say okay. And you can see here, this is absolutely stable process. There is not a single data point which is going beyond control limit. Okay. And lower control limit stopping at 0. Why? Because again, you cannot have -1 or -2 or -3 defective. Are you understanding? It can be 0 or more than 0, correct? That's why the lower control limit stops at 0 and upper control limit at 3.720. Okay. Now, the formula for calculating control limits. Okay, how many of you? Okay, anyways, I will come to that point. Till now, are you clear with this? The same procedure? Yes, C chart and NP chart is clear. Wherever we have constant sample size and defect data, go for C chart. When we have constant sample size and defective data, go for NP chart. Yahan tak, everybody with me, just type yes in the chat box. Yahan tak sab kuch changa si. Anybody in the room who is not understanding ki what is happening, especially the new people, just type me in the chat box. See, all the new people, there is one small request and suggestion. Okay. If you are very new in the system, it will take at least 2 weeks time, couple of weeks time, 2 to 3 weeks time. It depends on how much time are you giving. Okay. To understand the basic philosophy, the basic terminology. Okay. And to get used to it. All right. So give yourself some time. If you are confused in the first initial couple of sessions, it's absolutely normal. Don't worry about it. After, you complete lot of your green belt, as your green belt study progresses, all these things will make sense. All the dots will get connected eventually. Okay, so don't worry. Be a little patient with yourself. Understand. Check the recording of the video, which will be given to you again. You can increase the speed of the video up to 2x and check the recording later as well. Okay. Yes. So give time some time. Give time some time. Okay. Now, एनपी का डेटा दिखा देता हूं राजीव जी के लिए. So from the graph, how do you go back to the data? This is the short key. The short key is Control Alt D. Okay, when you press Control Alt D, you will directly go to the data. Okay, and this is the data where these are the samples in each and every event, and these are out of every event how many defective data were found. Okay, so this is the data for NP chart. Clear here? Yes. Super clear, everybody? Just type yes in the chat box. Now let's go for the third chart of this, which is called U chart. अभी U chart देखेंगे या पहले, हाँ ठीक है, पहले U chart देखते हैं. Everybody just open this file called U chart. Now, all these files also will be available. They are already available in your Greenbelt curriculum. And below the today's recording also, I will put this file so that you can download them and practice them. Okay. Just open this file, guys. And once you have opened it, let me know in the chat box. Okay. Now we are opening the U chart. The U chart. Okay. When do we use U chart? Whenever we have defect data and the constant sample size is not there. So variable sample size is there. Okay. Now let's open this. Now I've given you example here. The example is, yeah, everybody's opened it. Yes, opened. Let's try to find out the U chart. Now, what is U chart? When do we use U chart? When the sample size is not constant. Now, here the example is of a hotel, the rooms inspector. Let's say there is one guy who is a hotel quality control person whose role is to go in each and every hotel room and find out whether everything is in place before the customer comes in and occupies the room. All right. So now the day one, the person has inspected 14 rooms, out of which he has found 16 defects. That means now what are the different defects in the hotel room? Let's say the bed is not done properly. The toilet is not cleaned properly. The dustbin is not cleared properly. Okay. Or there are certain kind of stains, some food bags or packets. So all these are types of defects. Okay. So here he is actually calculating or collecting the data of the defects. Okay. Now, if this would have been the defective data, now understand this, huh? In one room. Now, one room is equal to complete unit, right? Now, instead of defects, if we would have defective data, that data would have been out of 14 rooms, 5 rooms defective. Out of 8 rooms, two rooms defective. Are you understanding the difference between defective and defects? Just type yes in chat box. समझ में आ रहा है defect और defective का difference? तो ये है defect data. He has actually collected the data of defects. How many defects are there? Total defects. Clear है? Just give me yes in the chat box. Super clear? Everybody? Just give me yes, yes, yes. Okay. Any doubt, please let me know. Okay. Now let's go to stat. Now we are doing U chart, right? So go to stat, control charts, attribute chart, and here you will find U chart. Stat, control chart, attribute chart, U chart. Okay. Just click on U chart. Follow the same process. Now you will be, see, even in the first session itself, you will get accustomed to this. Stat, control chart, attribute chart, stat, control chart, attribute chart. Okay. And then rest of the 4 options are there. So go to U chart. In the variable, select defects. In the subgroup size, select rooms inspected. Subgroup meaning the samples, the sample size. Okay, sample size is varying. That's why it is subgroup size. So you have to select rooms inspected and defects in the variable column and say, okay. Wow, this is something interesting, isn't it? This is something interesting. Now, what is this data? Just try to understand this data first, okay? पहले data को समझ लेते हैं. Go back to the data. Now, go back to the data. You will find here. So, how this data is plotted? Let's try to understand this first. So, let's say 14 rooms and 16 defects, right? So, 16 divided by 14. Maybe let's say 1.2. So, this 1.2 will be plotted in the first data point. Then 16 divided by 8. So, 16 defects found out of 8 rooms. So, this will be 2. Then 10 divided by 12. So, it will be maybe 0.8 something, right? So, this is how this proportion defects are basically collected. Clear hai? So these are basically plotted data points. And then they have taken the average of this. Clear? So this is called U bar. U bar meaning the average of this. And then the control limits are plotted. Clear, everybody? Now, why these control limits are looking like this? Because now understand this is very, very important. Now, because let's say 8 defect out of 10 and 8 defect out of 16 rooms, both are different. If I plot only 8 without considering proportion, okay, so then I could have what you can say, plotted the straight lines in the control limits, okay. But because the denominator is different, because the sample size is different, the control limits are calculated separately for each and every data point. For each and every data point, the control limits are separately calculated, and that is why you are observing these kinds of control limits. I will give you the formula to calculate control limits as well. But, okay, for us, what the most important thing is these 3 data points. Look at this. All right. So now here, anything which is beyond control limit, it's a special cause of variation. Okay. Now in this discrete control, control charts, anything which goes above control limit needs to be thoroughly investigated and action needs to be taken. Anything which goes below the lower control limit needs to be investigated because there is something better they have done. How many of you have understood this? Just try to understand this. Huh? If the data point going above control limit in this case, that needs to be investigated and immediately corrective action needs to be taken. But when the data comes below the lower control limit, these 2 data points, these have to be investigated, but you should not take any action because you are doing good over there. How many of you got it? Just type yes in the chat box. This is defect percentage. This is defect proportion. If the defect proportion is going down, that's a good, that is the desired state. So don't take any action. Let it be like that. But if it is going beyond upper control limit, then you need to take the action. How many of you got this? Just type yes in the chat box. मैंने Saturday को भी ये समझाया था आपको. If the people who have attended Saturday session, if you remember this, just type yes in the chat box. Clear hai? Yes, the control limits are changing every time because the sample size is changing, because the proportion is changing. That's why the control limits are calculated separately for every data point. Separately. That's why these kinds of steps are same. Okay. But anyway, for us, it does not make, it does not matter. What for us is there any red dot present? If any red dot present, that needs to be investigated, especially above upper control limit. Okay, anybody has doubt in this? The point which I discussed. If it is below lower control limit, don't take any action. Any doubt in this point? Just let me ask this. Clear hai? Yes. Blue lines are just the connected lines. Blue lines are just connected lines. Okay, the dots are plotted. हम लोग जब ग्राफ बनाते हैं ना, ट्रेंड चार्ट वगैरह, तो blue lines are just connected line. That's it. उनका वही काम है, बाकी कुछ काम नहीं है. Just whether you are going up or whether you are going down. Okay, that's it. Yeah, Shantanu ji, just type in the chat box. So the dots are plotted as I mentioned earlier. As I mentioned earlier, if you remember, the first data point was 1.2. You can see here. This data point, how it was plotted. This data point is 1.2 because there were 16 defects in 14 rooms. So 14 divided by 16 divided by 14, around 1.2. That's it. That is the dot is plotted over here. Okay. So the second is, so this is how each and every, it's a proportion defect. It's a proportion defect. What is my proportion defect? It is calculated. It is plotted on the graph. Okay. Yeah, continuous data below control limit can be investigated. No, yes, can be investigated. You need to understand. See, understand this. When your defect level goes down, you need to investigate what you have done right. Okay, then you can replicate as well. But don't take any corrective preventive action because that is the desired state. That's what I said. Got it, everybody? Yeah, for every, so there is a formula to calculate this. Okay, there is a formula to calculate each and every control limit separately. I will give you the formula as well. Now you need not to remember all this formula. I will give you the formula. I'll show you. I'll show you the formula as well, just for your understanding. In the same document, okay, there is a formula as well. Look at this. This is the formula for this. So the formula is, like for example, individual control chart. The formula is x bar plus 3 standard deviation, x bar minus 3. So upper control limit will be x bar plus 3 standard deviation, x bar minus 2 standard deviation. What we are right now looking at is a U chart. Look at this, U chart. So U chart, the center line is U hat. It is called U hat. Okay. For the discrete data, it is called U hat. For the continuous data, it is called X bar or R bar or X or S bar. Okay. So when you have continuous data, they have the bar sign over there. Let's look at this. X bar or S bar. S bar is the center line, or R bar, which is the center line. Over here, it is called hat. U hat, C hat, NP hat, or P hat. It is nothing but the average only. There is nothing difference in that, but it's called as hat. Okay. Now coming back to this formula of upper control limit for every data point is U hat, which is this value, plus 3 into square root of U hat in bracket 1 minus U hat bracket complete divided by n. N is equal to number of data points, which is room inspected. In this case, room inspected. Okay. The same goes with the lower control limit. So for every data point, this will be calculated separately. Clear, everybody? Just type yes in the chat box. Yes, exactly. Yogesh ji, you are right. So we need to investigate and learn from it. What has gone wrong? What has gone better for us? Okay. It's a formula to calculate this control limits. 3 into square root of U hat into 1 minus U hat bracket complete divided by n. ये कंट्रोल लिमिट का फॉर्मूला है, अपर कंट्रोल एंड लोअर कंट्रोल लिमिट को कैलकुलेट करने का. ओके, आपको रिमेंबर करने की जरूरत नहीं है. डोंट वरी, दिस इज द फॉर्मूला आई हैव जस्ट शोन यू बिकॉज़ यू वर क्यूरियस ये निकाला कैसे है. ओके, सो दिस इज द आंसर टू दैट. क्लियर एवरीबॉडी? जस्ट गिव मी यस इन द चैट बॉक्स. सुपर क्लियर है? Just give me yes. Fantastic, fantastic. And how CPL and yeah, clear hai na? Any further doubt? You can just ask me, okay? And again, it will take a little bit of time to understand, but don't worry. Let's just be patient and understand the concept. All right. We have software with us to calculate all these things for us. Okay. So we need not to worry about it. Now coming back to the next part, which one is remaining now? P chart is remaining. Okay. P chart is remaining. So let me just quickly share the data of P chart. So look at this P chart file. Just download this file. Now, by the way, for the new people, we will open the question answer forum after the session is over. Okay. We'll open the forum for everybody. So you can unmute and ask the question as well. Any doubt for today's session or any other session as well, you can ask the question. Okay. So yes, download this file, please. Once you have downloaded, let me know in the chat box. Okay. So this is the fourth one, which is called the P chart. So all the 4 charts we are actually checking today. So in this case, what in the P chart, what we do? It's a defective data. It's a defective data. And the sample size is not constant. Okay. For example, in one class, there are 50 students. And this is the failed data. Okay. So let me say it is a failed data. How many failed? So how many students were there and how many failed? Okay. So in 50 students, 0 failed. Okay. Second also 50 students, 0 failed. The third option, the third class, 60 students were there and 1 student failed. Okay. Again, in the 7th class, 80 students were there. So this is the data of how many students are there. And because the sample size is varying, we are going for P chart. Okay. The same process, stat, control charts, attribute charts, and we have to go for P chart. Just follow this path: stat, control charts, attribute charts, and P chart. So click on P. The variable is here is failed data is our variable. And in subgroup size, just type sample size. Just double click on sample size. Okay, I have this. In the subgroup size, select the sample size. Okay, everybody, in the variable, just type failed, and the subgroup size, just type sample size and say okay. Wow. Now again, the same fundamental. This is calculated separately for every data point. Okay. But again, we cannot have negative numbers here. We cannot have -2 students fail, right? So either it has to be 0 or 1 or 2 or 3 or 4, right? So that's why the lower control limit stops at 0. Okay. So again, the same funda remains. If anything above upper control limit, you need to investigate and take corrective preventive action. If anything goes below control limit, you can just check what has gone better, what has gone, what is doing, what is going well in this process, and do not take any kind of corrective preventive measure. Okay, let it continue. This is called P chart. So now this shows that there is nothing, what you can say, there is nothing called out of this control limit over here. Everybody with me? So see, control limits. What is the difference between control limit and specification limit? Control limit is decided by the process itself, and specification limit is decided by the customer. Are you understanding? So there is nothing to do with the specification limit here. Process itself will calculate a control limit. You need not to have the customer specification limit to insert here. Here? Yeah, we can do that, wrong? हम लोग अभी करके देखते हैं. चलो कुछ डेटा डाल के रखते हैं. So let's change this. Instead of this, let's say put 8, Here, let's say put 9. Okay, let's say put 11 failed. 40 may say maybe 6 failed, etc. Okay, so I just put some data and I will do this graph once again. Can you see here? I have changed the data now that the process is unstable. There are 4 data points which I've just mentioned earlier. They have gone above the upper control limit. And these classes have to be basically checked. So if you are the headmaster of the school, these are the batches, or these are the classrooms. You need to put more focus because the percentage failing proportion is very high. Clear, everybody? Just type yes in the chat box. Super clear. Everybody just give me yes in the chat box. Now, Chandrasekhar ji, what we have done is I just went to this data once again, and I just put some more failure data. Okay, for example, here I just put 80 में से 9 failed. Okay, 80 में से 11 failed, or 40 में से 6 failed. You can also do this. Okay, variable same. उसमें कोई change नहीं किया मैंने. When you change the data, see, software has got a capability to pick up the changed data and update the graph immediately. Okay. Can you please explain IMR chart? हाँ, same chart है ना, हम लोगों ने किया, हम लोग IMR भी करेंगे. Okay. Clear है ये समझ में आ गया? Just type yes in the chat box. So इसमें भी failed ही आएगा, sample size ही आएगा, and just say okay, you will get a graph. This graph you will get. Okay. Super. Yeah. So on Saturday we had seen the eye chart, right? So एक chart हम लोग निकालते हैं, which is a continuous chart, which Purushottam is asking. Just let's go for this eye chart option. I'm just sharing one file with you guys. Okay. Just open this file and we will just make the eye chart out of it. Okay. Let me also open this. IMR chart हम लोग बनाएंगे. I and MR chart. MR is moving range and I stands for individual. Okay. Individual moving range chart. So let's try to understand what is individual moving range chart. Once you open this file, let me know in the chat box. Now this is the continuous data, continuous file. Okay. So we have already covered the 4 discrete control charts today. This is where, when we have the continuous data, let me just share my file, share my screen. Everybody got this? Open किया आप लोगों ने ये फाइल? एक बार ये भी कर लेते हैं फिर से. Then I will give you a homework to study. I have already done this class earlier. Open, just give me yes in the chat box. Very good. Now, first we'll make eye chart, then we'll make IMR chart. Okay, both charts we'll make and then we'll compare them. Okay. Stat control chart. Now, instead of attribute chart, now we are going for the variable chart for individual. Okay. Now let's calculate the individual first. We'll first calculate individual, which is the first basic control chart invented by Walter Shewhart. This was that chart, individual chart. Okay. Now click on that. Select chocolate weight in the variable. If you are behind this, go to stat control chart, variable chart for individual. Okay, just follow this path. Stat control chart, variable chart for individual. Click on that. Double click on chocolate weight in the variable and just say okay. Now you would have gotten this chart. Have you got this chart? Just type yes in the chat box. This is called the first basic chart which is, yeah, sequence is the same. Stat, control chart, variable chart for individual. This is a sequence. All right. Everybody got this chart? So this chart actually shows how the variation is happening. Okay. And so this basically this control chart this is the mean. This UCL, the formula is X bar plus 3 times standard deviation, and LCL is X bar minus 3 times standard deviation. Okay, this and this. So these control limits are calculated. So only one point of the boundary line you can see. Otherwise, the data is more or less stable in this case. Stable and predictable. Okay. Now let's come to moving range chart. Okay. Let's go to stat, control chart, individual. Now, instead of individual, just select IMR chart. IMR is individual and moving range. So instead of one chart, we are going to plot two charts. I chart will remain exactly same what we have plotted. Apart from that, we are going to plot moving range chart. Now, what is moving range? First plot it, then I will explain you. Okay. Same process. Hai. In the variable, select chocolate weight and say okay. Now look at this. Now we have plotted, instead of one chart, we have plotted two charts over here. Okay, instead of one chart, we have plotted two charts over here. Now let's try to understand what is moving range chart. Okay, what is moving range chart? Moving range chart is nothing but, now how these dots are plotted. Okay, how these dots are plotted. Let's go back to the data. Try to understand this. Okay. So the first chocolate weight is 42.1, correct? The second chocolate weight is 40.7. What is the difference between these two? What is the difference between these two? Type in chat box. Is it 1.4? Everybody got this? Difference between these two data points. 1.4. Are you understanding this? Just type yes in the chat box. Okay. Now the difference between the second and the third point, 40.7 and 40.3. What is the difference? 0.4. Are you understanding this? Just type yes in the chat box. What is the distance between 40.3 and 42.3, which is 2.0? Are you understanding this? Just give me yes in the chat box. So for every data point, how much the next data point is moving? Okay. What is the range? Maximum minus minimum. What is that? What is the formula of range? Range का मतलब क्या है? Range का मतलब क्या है? Maximum value minus minimum value. Okay. So in this clear? Super. Am I audible? Is it clear? Just give me yes. Moving range clear hai? How do we calculate it? Okay. Now just try to understand this. Let's say if the distance increases, if the moving range increases, that means there is a sudden shift in the process. Yes or no? From one point, the next point is, let's say, 4.0 grams ahead or less, that means there's a sudden shift. So moving range immediately captures that shift and asks us to investigate. Now let's go back to the moving range now. Go back to the graph. Now look at this. So here we have plotted all these moving range one by one. And you can see here, these are three data points which have gone above control limits. That means there is a sudden increase in the range. Okay, can you see here? From this data point, it has shot immediately to this. From this data point, it has got this and then this. Are you understanding? So these three need some investigation. What has changed over there? And you can see the reflection over here as well. Can you see here the reflection of this sudden shift and reflection over here as well? Okay, so sudden shift reflections, you can see these two portions needs to be investigated. Clear, everybody? This is called IMR chart. So MR gives us a next level of what you can say range, which is the variability, okay, indicator, so that we can find out some abnormalities in the data as well. Clear, everybody? Just type yes in the chat box. This is called IMR chart. Here, just give me yes. Very good. Now, I have got one homework for you guys. Okay. Before we connect in the next session, I want for the people who have not attended the Saturday session. All right. Look at this. So let me just go back to my master class archive folder. मास्टर क्लास आर्काइव फोल्डर को मैं ओपन कर रहा हूं. Just yeah, so I'm just opening the yeah, I think there's a glitch in the internet. I'm coming back again. Once you open any session over there, guys, everybody's back. Just give me yes in the chat box. Everybody's back. Just give me a confirmation. Yes. Okay. Now look at this. So once you open any of the session, okay, go on the left-hand side. You can see here, there is a search menu. Okay. In the search, in the search menu, you can see here, you need to just write this down. This is your homework. Just put binomial, Poisson and binomial process capability. Can you see here? So this session is your homework. So the date was 27/24, Poisson and binomial. Now, this is the process capability analysis of the discrete data with the help of Minitab. Just check this session. You will find all the details. Okay. Everybody clear hai? Just type yes in the chat box. So I will just, if I can, no, I can't. Yeah, binomial and yes. So this is I'm just putting it in the chat. I'm just putting that in the chat. This was me without beard. All right. So this is the homework for you. Okay, everybody, before we connect on Saturday, can you just check this out? Just give me confirmation in the chat. You will find it in the masterclass archive 27-24 का session है. This is an extension of today's session, and you will enjoy this session. Okay? ठीक है जी. Super, super. Chalo. So I am open for the question answer. If you have any question, all right, for the new people, guys. Meanwhile, you have any query, this is the number for you. Okay, this is the number for you. Just check this number, and this is only for the WhatsApp, not for calling. All right. So any query you have, whenever you are doing a project or when you're stuck in the studies, or okay, just send a message on this number, WhatsApp number. Save this number, by the way. If this number is not saved yet, please save this number right away. Okay. And if you have any questions, any queries, you can ask it right now, or you can ask it later on that WhatsApp number as well if you have any specific question about this. Okay. Yeah. So for the new people, okay, for the new people, once you get the login ID password, all right, what you need to do is I'll just share my screen once again. You need to basically start your journey with the Advanced Lean Six Sigma Green Belt Certification course from SNG. Now, this is, even though question is asked by Mr. Azhar, okay, this is very, very important question applicable to everybody. Okay. So the people who are the new beginners, okay, start your journey with the Green Belt Certification course, and just these are just 3 minutes, 5 minutes videos. Okay, just check these videos and take the notes, connect the concept with your own examples. Okay, and attend the live session, ask the questions in the live session, ask the question on the WhatsApp number provided to you, clarify your doubt. Lot of Minitab exercises are given over there. Please follow the step-by-step guide which has been given. Okay, just click on the start button, just check this, just practice this with your own data. Okay, just follow this principle. Okay, attend the hackathon which will be happening monthly, the Green Belt hackathon which has just happened just 20 days ago. Next month also it will happen, Green Belt hackathon, where we will what you can say, complete entire course revision in the 3 days, where you can come attend this, and then we can give the exam, or you can give the examination individually as well. So you not to give the exam in the group, you can give the exam individually whenever you are done with the study. Okay, if you have taken some notes, etc., you can submit the notes for the mentor's guidance. Mentor will check whether your notes are in line with the course or not. Okay, some suggestions are there, they can provide you the guidance. The sample notes you can check over here as well. Okay, you can see here. All right, please prepare your own notes. All right, the sample notes are put over here, so you can just check the sample notes. I'll just show you a couple of sample notes over here. Now it can be electronic notes. Okay, the notes which are the on the PowerPoint presentation, or the what you can say, the Word document, PDF format. Okay, or it can be simple handwritten notes, whichever is basically suitable for you. You can use these notes. Okay, yeah, it is taking a little bit of time for downloading because the net speed is okay. Look at this. So these are some of the the notes you can see here. Now the screenshots are taken, and then he has taken the screenshot from the course, and then the explanation. Okay, so screenshots and the explanation. Can you see here? This way also you can prepare the notes. Okay, so various screenshots he has taken, and the notes are taken. Okay, so you can take your own notes, right? Yeah, so it's not compulsory, but this is just for reference, because see why the notes are important. See, this subject is very volatile. Try to understand this. Okay, now when you take the notes, what happens is those notes can be referred in the future as well. Those notes can be referred during the exam as well, because the exams are open book exams. So notes become very handy during the examination. Okay, so I would highly recommend, please make the notes. I'm still referring my notes which were made 15 years ago, 20 years ago. Today also I'm referring my notes. So they are very, very powerful one. Okay, super, super. Amazing. So that's it from my side. We will connect again. And if meanwhile any doubt, the number has been given. You can connect on us on admin@panelgiving.com as well. But WhatsApp number is the faster. Okay. Yes, it's like petrol. Yes, exactly. It's like petrol. Okay. Thank you very much for joining in. Keep learning, keep growing. This is Dinesh Patel signing off. Good night. Take care. Bye bye.